Hi everyone. In this video I'm going to talk about the exact values for the unit circle and where they came from. Keep in mind that in doing this it's going to be really important for you to actually remember these values, so whether you commit the table to memory or otherwise the triangles to memory, we need to have those values, okay? Hopefully it'll just be a bit of a refresher on what you've done in the last year. So the exact values, they come from two triangles which can be formed inside the unit circle. The first one is a right angle triangle, so I'm just going to draw that here. So it's an isosceles right triangle. Might not look like it particularly, but I'll just do that and make it all okay. Alright, so because it's isosceles, that means we have 45 degrees in each of these corners. And this one, it has a height of 1 and a base length of 1. So using Pythagoras' theorem, we can quite quickly and easily figure out that the hypotenuse of this one is going to be square root of 2 in length. So using this, we can really quickly and easily come up with values for sine theta and cos theta. So I can write sine theta equals, now if I use this angle here, now sine theta is the opposite over the hypotenuse, so that is 1 over the square root of 2. Which you might choose to write as root 2 over 2 by rationalising the denominator. Both are the same. Okay, same goes for cos theta. So cos theta in this case is the adjacent over the hypotenuse. So adjacent to this angle here is 1, and the hypotenuse is still root 2, so that's also 1 over root 2 or root 2 over 2, whichever way you prefer. As for tan theta is opposite over adjacent, so the opposite in this case is 1, the adjacent is also 1, so it's 1 over 1, which is just 1. Made a slight mistake there. I should have written 45 degrees in each of these cases. So I'll just go back and fix that up. Okay, so then we have another triangle, and this one is actually an equilateral triangle. So I'll draw that here. So an equilateral triangle has 60 degrees in each of the corners. Unfortunately, we can't do many calculations with an equilateral triangle, so what I'm going to do is I'm just going to cut it in half. Okay, make it a nice right angle there. So if we made the original side lengths 2 each, just for simplicity, then when we cut it in half, there's only 1 left there. This side here is still going to be 2, and again, using Pythagoras' theorem, we can calculate that the height of that is the square root of 3. What we still have here is 60 degrees in this corner and 30 degrees in this corner. So based on that, we're able to come up with the other values. So if we go sine 30 degrees, so the opposite over the hypotenuse is 1 over 2. If we do cos of 30 degrees, we're going to do adjacent over hypotenuse, which is root 3 over 2. And lastly, if we do tan of 30 degrees, that is opposite over adjacent, which is 1 over square root of 3, which you might prefer to rationalise the denominator and write as root 3 on 3. Alternatively, we can do sine of 60 degrees, which is opposite over hypotenuse, or root 3 on 2. We can do cos of 60 degrees, which is going to be adjacent over hypotenuse, and also tan of 60 degrees, which is opposite over adjacent, so that's root 3 over 1, which we can just write as root 3. This leads to a table of values, which I will set up in the next video.